Welcome to the presentation. Today we will be learning in details about data cleaning. So data cleaning, as the terminology tells you, it is after the data has been collected and the data has been tabulated. It's like looking into the data and finding out or scrutinizing the data for a possible error which might be there in the data. And this is a common exercise that is done by data analyst before a data analysis is been done and after the data has been collected and tabulated, or it is placed in any of the softwares for tabulating. Initially, when I heard about data cleaning, I thought that data is to be possibly washed and do some amount of cleaning is been done into it. I took it literally, but later on when I studied, I found that this is an exercise which is commonly done by data analysts before they actually subject the data available before analysis. So let us look at a formal definition of data analysis. Data cleaning. What does data cleaning actually do? Data cleaning includes consistency checks and treatment of missing responses. Uh, Such checks are generally done by the computer and not manually. This is some advantage that the computer provides for dealing with data is concerned. Manually looking for consistency checks in the data might be sometimes cumbersome, difficult, and sometimes impossible as well, depending on the size of the data. Also, many a times in case of consistency checks, you don't have to restrict your view to or your attention to one variable only, but it might be dependent on several other variables. So those things can be nicely handled with the help of an electronic data processing source, like using some software in a computer for analyzing your data. Obviously, you have to look at some missing responses which might happen in your database, and application of both these things require the use of computers, especially when your data or the number of observations are huge and large in number. Data cleaning can be done in a very common software like Microsoft Excel as well. Let us take some example to understand what is data cleaning and how they are implemented. But before that, let us look at a abridged view of a questionnaire. So this is suppose some personal details is collected. In most of the questionnaire, you will find that it starts with collecting some personal details about the respondent. These personal details does not participate seriously in the at the time of analysis, but these personal details are very important in if you want to get back to the respondent for some purpose. Now here you see I have filled up the previous questionnaire for a particular person whose name is Dhananjay Tiwari. He stays in Bihar. The serial number of the questionnaire is 32. His age is 27. He has an address also, and we have his phone number and email ID. Now, when this data is taken to a database, this is and we have taken an Excel screenshot. So what happens, you see these variable names, they actually take different column headings. For example, serial number heading of the first column, state, second column heading, name, third column heading, age, fourth column heading, address, fifth column heading, email, sixth column heading, and the mobile number, this is the seventh column heading. So these we different column headings we have. After that, we actually, this is our raw data. Now this raw data is converted into a tabular format data, and as you can see here, the data entry has started. The first questionnaire that we have in hand is already been entered, and the names have appeared under, or the values have appeared under the name of the variables. This way data is being populated, and with each additional questionnaire we actually populate one more new row. The number of columns remains the same. It only changes if the number of variable changes or the number of variable increases. Otherwise, the number of columns remains the same. Now, once the data is entered and all the data from all the questionnaires are placed in the format that was shown to you in the previous slide, we actually subject the data to data cleaning. Data cleaning basically consists of two steps. One step is the checking for consistency, another treatment to missing responses. So let us look at what is consistency checks. So consistency checks, it comprises of identifying that the data are, number one, is there any observation which is out of range? Is there any logical inconsistency is there? Now, if you look at out of range data and whether there are some extreme values in the data set. So these three things we are doing in consistency checks: checking for out of range data, checking for logically inconsistent data, and checking for sorry, extreme values. So if we look at out of range data, out of range data consists of, suppose we are collecting information from an individual in a scale of 1 to 5. So the question is whether there is a code more than 6 in that particular data set. Means some possible value 6 or more than 6, because 6 is not a uh, uh, possible value in the scale. So if the value is more than 6, then it is an out of range data. It is 1 to 5 in the scale. For example, if I ask someone that your experience in our hotel was so miserable and mind blowing, these are the two verbal descriptors, bipolar verbal descriptors, and in between we have a scale from 1 to 5. Now, in this particular scale, any person who is filling up the scale will put his tick in any one of the values from 1 to 5. So, those are the possible values that the data set will have under that particular variable, say experience. But if we look into this data set, and if we find there is a number more than 5 or say less than 1, it is 0, then we understand that there is some misconception or there is some error in the entry of data. So this is an out of range data. Next question is like, suppose we are collecting phone numbers of individual. Many people are providing their landline numbers. So landline phone numbers are generally in our country in India. It generally consists of at least 6 digits. Some places have 7-digit numbers. 5-digit numbers are rarely available. So some people are quoting 5-digit phone numbers. Now whether this is really out of range, that needs to be checked. Might be in some places still the 5-digit landline number exists. So before actually declaring such a data value or such an observation as an out of range data, one needs to actually look into it and find it out whether it is really so. Then we have say another problem, that can a mobile number start with any digit other than 7, 8 or 9? In India, the mobile numbers are either starting with 7, 8 or 9. However, these days some numbers I am finding that they are starting with 6 as well. Now, when we look into such a data set, and if the person who is dealing with data is not aware of the fact that some mobile numbers are coming up with 6 as the first digit, so he may declare that particular data or that particular phone number as obsolete or out of range. But a nice way to check it is to call that particular number and check it out whether it rings or not. If it rings, then that means it's working. And the mobile agencies have started allotting phone numbers which start with for starting digit is 6. So this is called as out of range data. Such data sets are to be checked before declaring them as out of range data. And for example, can a person write 111 books in a year? Suppose a person, we are collecting information about number of books written by different individuals in an organization, say in a university, and we find that some people have written 1 or 2 books in that year, but one person claims that he has written 111 books in a year. Even 111 books in lifetime is seems to be an abnormal number. And so this is to be checked and to be found out that whether really it happens or not. So some out of range data may be created due to mistyping or uh, by error, but some out of range data may not be actually out of range, so they need to be scrutinized before declaring such data sets as out of range data. We go to consistency checks, and now we look at the next option, that logically inconsistent. Some data sets might be logically inconsistent because if we look at some data set, logically inconsistence happens due to two reasons, not due to two reasons, sorry. Logically inconsistent data actually comes into existence because of mismatch of responses in two or more number of variables. That is, one variable response actually is related to the response to the other variable. Let us take up this particular example. Age of the mother is 28 years and age of the son is 19 years. Now, this is because age of the son is related to the variable age of the mother. Now, if the mother is the biological mother, then this is not a possible option. That means mother's age 28 years and a son's age is 19 years. That means she became mother at the age of 11 years, which also say at the age of 9 years, which is not possible. So this is not something which is possible. But if she is not the biological mother, if she is the stepmother, then there is a possibility of such things happening. So this needs to be checked, but otherwise from the overall view, it appears that this is a logically inconsistent type of data. Let us have some example like this, that do you have a car? This gentleman, he is walking and someone asking, do you have a car? His answer is no. Then the next question, if yes, what is the color of the car? To that question, in a questionnaire, this individual has answered as blue. That means he does not have a car, but he tells that the color of my car is blue. Now, this option is not possible because you cannot have simultaneously two things happening. Because if you don't have a car, right, you cannot have a car with of any color. So they are logically inconsistent. That means answer to this particular question, or the answer to this value of this particular variable actually controls the value of the next variable. So such are examples of logically inconsistent data. Let us now look at if some data set have extreme values. Now, when we speak about extreme values are large values or very small values for a particular variable, which might be improbable but may not be impossible. For example, if we take that one should handle the extreme values of data very carefully, because then it's to be checked and identified whether it is an extreme value or it is an something which is not possible or wrongly printed. To certain extent, you may call it out of range also. So there is some similarity between extreme value and out of range. Out of range is some value which is not possible because it is not within the range. Extreme value means some very high or very low value compared to the other observations in the data set, and this looks handsomely improbable. One should handle such extreme values of data very carefully. Extreme values may not be indication of an error, but values should be used after proper verification. When you really find an extreme values, that needs to be scrutinized. The second point means that a run sequence plot can be used to identify the extreme values of a data set or by standardizing the data. Now let us look at this run sequence plot. Let us look at these observations. These are the number of books written by 10 professors. So these are the 10 professors, their serial number, and this is the number of books they have written in their lifetime. Now, what is a run sequence plot? Run sequence plot is a plot like this, that corresponding to the value 1, I am plotting the number of books. 2, next corresponding to 2, it is plotted 0, and then we get a line graph like this. This is called as a run sequence plot. Now, in this plot, we find that there are two extreme observations, like one is having 15 number of books and another is having 11 number of books. Now, that is not improbable. That is not impossible, but seems to be, given the other observations, this seems to be very high. So you can quickly run a check of this with those professors and finalize your data set. So that is how we identify extreme values. Some cases we standardize the data. Standardize the data means we just make a transformation on the data. We calculate the mean and the standard deviation of the data set. It is mean of these observations and the standard deviation of this observation, and then get a new column which is this value minus mean, whole thing divided by the standard deviation. For example, if the mean is say 5 and divided by standard deviation is say 10, so 2 minus 5 divided by 10. So that way we go to standardize the data. Now, after standardization, if we find that some values are there which is actually less than say minus 3 or more than plus 3, so that is something which is improbable, not impossible. So we can have a very quickly look at this, like if you want to compute the standardized data set, how to compute it very quickly. Let us have a look at this. For example, suppose this is my data set. Say I take the number of books column. So we number of books column, and then we escape to Excel, and then we open a new sheet. Suppose this is a new sheet. Here I type in this value. Okay, so number of books, number of books this, and then I calculate the mean here and the standard deviation. These are just I am putting this text as guidelines of what I am doing here. So this mean is equal to, so this is average is 3.8. And now we compute the standard deviation. STDEVP is the command for standard deviation. Then we come to this value, close the bracket, find this standard deviation. Sorry, ST, there is an STD, STDEV, DEVP standard deviation. Okay. So this is the standard deviation. Now for this we have the here the standardized values, STD standardized values. So what we do, we take the value, that is this is the value, then we put it within bracket. Then we take the minus 3.8, that is the average 3.8, close the bracket, and divided by standard deviation, that is 4.77. So we write 4.77 and we press enter. So this is minus 3.377. We come up to the last value. So here you see all the values. So there is none of the values. Even 15 is 2.3 but not beyond 3, and 11 is 1.5 not beyond 3. So these are possible values. These are not improbable values, these are probable values. So this number of books, so if say some book, say someone has written, suppose this person has written 111 books, then you see the value goes up so high as 22.7. Even say he has written say 25 books, then also you look at this 4.44. So this is more than 3. So this observation is an extreme observation, a very high value, and you may check it out whether this is really possible or not by calling that particular professor. So this way we can use Excel for doing these small exercises of standardizing the data. So we come back here in SPSS and other things, standardization can be done automatically. We don't have to type in the formula. So now coming back to this presentation. So once we have the run sequence plot, okay, now let us see what are the treatments that we can give to missing observations. So missing responses generally take place when a person does not want to respond to a question, or the value is not recorded by mistake, or that particular person does not fall under that category or have not experienced that. So these are the cases when missing responses takes place. And if you don't actually take care of the missing response, so then we have to cancel the entire all the individuals, all the information coming from that particular individual. Now this is something which we may not afford, especially if our database is small in size, because other information from that individual is available. Only one particular or two particular or some few observations are not made by that individual. So these shall not lead to the rejection of the entire data set. So represent the values of the variable which is unknown. Respondents may provide some ambiguous answers, and also may not information may not be recorded or may not be available. Such are the cases when missing observation takes place in a data set. Now question is what we should do with the missing observation. Now first thing is that we can directly cancel the entire observation totally. But the thing is that, as we told earlier, this cannot be done if the sample size is small. If we have a lot of data, we can do it, but if we have less data, we shall not do it. A neutral value, especially the average, may be a replacement of the missing observation. So these are sometimes been done, that suppose age of the respondent. So I have collected the age of the respondent. Few people, they have not recorded their age. So in that case, we can use the average age of the other respondents who have provided in that place, and we can get the average age of the respondent. So that way we can proceed. But the case is that when there is a categorical data observation, for example, suppose sources of drinking water. Suppose I have 4 sources of drinking water. They are coded as 1, 2, 3, and 4. Now, one person or few observations are there who have not reacted to that particular source of drinking water. Obviously, they have some source of drinking water for their livelihood. They cannot go without it. So it is not that not available. It should be available, but they have not recorded. In that case, we cannot use the average concept because 1, 2, 3, 4. If you take the average comes out to be 2.5. Now 2.5 is not a option available, so we cannot give a source of drinking water for them as 2.5. That means categorical responses cannot be used in that way. But if we look at this case, that okay, then this is a missing observation has taken place in case of categorical data, then the problem is that to certain extent that problem can be solved instead of averaging, looking at the trend of other responses, that in other statements or other variables, what are the responses. For example, suppose LCD, that we are taking a count of a number of things which might be available in household, like say two-wheelers, four-wheelers, LCD TV, music system, etc., etc., home theater, etc. We are residing. Now we are taking some socio-economic other information, also name of the individual, address, rural, urban, own house, rented house. Okay. Now it might be a trend visible that many people have LCD home theater, LCD TV at home, big LCD TV more than 42-inch in their home, or more than 40-inch in their home. But those people who are residing in their own home, they are taking a home theater also along with the television. But those who are residing in rented house, they are not taking a home theater, they are watching big TV, but are satisfied with the quality of sound produced by the television, not going for a home theater. The reason behind it is that maybe that they are staying in rented house, so they don't want to increase the number of assets, or rather too much of sound might disturb the other people residing around them in that particular home, because there might be other tenants also in that particular home, or even at least the landlord is there. So for that this is not been done. And so there is might be a trend that those who are residing in own houses and having TV more than 40 inches, they are also having an LCD, they are having a sound system, that is home theater. And those who are having television of less than 40 inches, but sorry, more than 40 inches, but staying in rented house, does not afford or does not purchase a home theater. This trend might be quite visible in most of the houses, so that information can be used to estimate what might be the missing response relating holding of a LCD at home along with home theater. Now some examples are there, some objective techniques are there with the help of which this can also be computed. For example, we have a regression tool which can be done. And these are, for example, these are the name of the player of some batsman, and who played in say a particular this thing, IPL, Indian Premier League, and this is their performance score. So the performance score is a number between 0 to 1. Higher the score, better is the performance. So we have computed it like this. There is some formula with the help of which this computation is done. But the ICC rating of some players are not available. For example, ICC rating of this player is not available. ICC rating of this player is not available. Now, what we want to do? We want to do some analysis. Say, I want to find a relationship between ICC rating and performance score. But the problem is that I don't have value corresponding to number second and fifth observation. And so one option is of dropping them totally, that my data set will just in such a case become smaller in size. But another way is to estimate this. So as I told earlier, a simple method is to take the average of the other observations, replace it there. But then another way is there, that based on this of ICC rating and performance score of the available, we can fit a regression line. As you can see that we have fit a regression line, and the regression line is like this, that ICC rating equal to this into performance score. So this is the value of this is the regression line. Now using this regression line, we can estimate the performance score of, say, I don't have the performance score of say Badrinath, but Badrinath's sorry, I don't have the ICC rating of Badrinath, but I know his performance score. So what I do, I replace the performance score of Badrinath in this equation, and then I find his ICC rating as this. and I replace the performance score of far duplexes here in this particular same equation in case of performance score, and I get an estimated value of the ICC rating. So this is a simple way of getting. We can have multiple regression also if there are many variables, and we can use it as an iterative technique that now I can put these, replace these values in the table where there is NA, and then I can, based on that, I can update my information, and I can go on repeating it unless and until we reach very close results. So this way we can go ahead and perform the regression tools uh, for the purpose of estimating missing observations. Sophisticated statistical tools are developed to solve this issue, like multiple imputation by chained equations. This we can avoid now, but this is called as MICE, multiple imputation use chained equations. Some softwares like R actually provides the option of computing the missing observations, and also we can otherwise manually also do it with the help of some multiple regression tools. But this is quite successful in estimating missing observations. This way we can avoid the missing observations, and then we can go forward for finding out missing observations. So this is all about data cleaning and how and what type of treatment we should give to missing observations. So we have learned in this about consistency checks, about identification of extreme values, and what treatment or how to estimate the missing observation. That's all. Thank you for watching this video.